All right. So if I think of this quadratic equation, 2x plus 4x plus 1 equals 0, right? This is written in the form, and we're going to see this a lot, ax squared plus bx plus c equals 0. So what we want to do is we want to draw this or rewrite this in a way, and we'll do this with a couple of these. Let's rewrite this as ax squared plus bx equals negative c. So what I'm going to do is I'm just going to subtract 1 from both sides, and I would get 2x squared plus 4x. And then when I subtract 1 from both sides of the equation, I get equals negative 1. Okay? And so then what does that, and we're going to, we'll circle back to this, but just write this down. It might not make sense, but this is the algorithm that we're going to use to solve quadratic equations by completing the square. And then on top of that, they want us to, that we're going to have what we call a negative discriminant. So we'll have a complex solution. Okay. So then in the next step, I want to rewrite this as ax squared plus bx. Okay. And so then that would be 2x squared plus 4x, right? And then in the last step, we're going to write g of x is equal to negative c. Okay? So then I would write g of x is equal to negative 1. Right? And we could do this with all of these equations. We could do this with multiple equations, but I'm just going to do the one. So now let's graph. In other words, well, let me write it down. All right. So that's one variation of it. And what we're going to do is we're going to break this down and see. Remember, we were talking about transformations of functions. And we're going to try to determine what all these mean. So if I do this with a plus 2, then in here I get 2x squared plus 4x. Subtract 2 from both sides, I get negative 2x. And then over here, this is still 2x plus 4x. And then my g of x is equal to negative 2. And then if we do this a third time, we're going to get 2x squared plus 4x plus 3. And so we get 2x squared plus 4x equals negative 3. And then over here, we're still going to have 2x squared plus 4x. And then my g of x is equal to negative 3. And so what we're trying to determine is, what is it that we're actually doing? How many solutions do we have? Are there solutions? Like, what's the difference, right? So let's graph this. So turn on your graphing calculator. And let's see what the big whoop is about. What's the big deal with all this stuff? So I think the class before you, we were working with some stats. So you may need to go in second y equals and go down to 4 to turn the plots off. And then hit y equals. And what I'm going to do is I'm going to graph all three of these. Okay. So the first one I'm going to do is I'm going to say 2x squared plus 4x plus 1. Then for the next line, I'm going to put 2x squared plus 4x plus 2. Then for the next one, I'm going to say 2x squared plus 4x plus 3. And then I'm going to graph. And let's zoom in. Let's do the window. We'll make x equal -5. And let's make x max 5. So you click on window to get to this menu. And then for the y value, let's do -5 to 5. I want to zoom in a little bit. Okay. And so what is it that it looks like we're doing with that graph? Yes.
What did you put in for the
-5 to 5 for the x min is -5, the x max is +5, and then for the y min -5 and the y max 5. Yes. Sure. I thought I did. Oh, you know what? I did not. Good call. All right. Okay. So what are we doing with those graphs? Well, let's see. That C term does something to the graph. So let's go ahead and graph 2x squared plus 4x just by itself. And then we'll see that the original graph is this one in purple. And then when I add +1, it looks like it goes up 1. When I add +2, it looks like I go up. So now next, go to y equals. And so what I'm noticing is some of these graphs tend to cross the x-axis, and some of them do not. So let's look at that. I'm going to zoom in on this. So let's unpack this. Remember, and you'll want to write this down, solutions to a quadratic is when y equals 0. So can have up to, oops, wrong, two solutions and then I want you to write it's a second degree polynomial. So that's no accident. If x is raised to the second power, then that means it's probably going to cross or could cross the x-axis 2 times. So you get 2 solutions. Remember that when y equals 0, that is the x-intercept. That's where it crosses the x-axis. So let's find those. The original one, so let's start labeling this. That original one, 2x, so I'm going to say f of x is equal to 2x squared plus 4x has 2 solutions. Oh, let's insert this word here, real solutions. Okay, so f of x equals 2x squared plus 4x has two solutions because it crosses the x-axis twice. This next one, which is the blue graph, which one is that? Do you guys remember? Well, let's look. The blue one is x plus 1. So what we've done is we've shifted this up, but it has two solutions. So if I say f of x is equal to 2x squared plus 4x plus 1, that also has two solutions. Oops. Because that crosses twice. Now, when I look at the next one, which is f of x equals 2, and insert, I keep skipping this, but say two real solutions. So there's two solutions for sure, but we're talking about two real solutions. Now, that means it's a real number solution. 2x squared plus 4x plus 2 only crosses one time. So that's one real solution. And that's probably a multiplicity of 2. And then the next one is f of x is equal to 2x squared plus 4x plus 3. And that has no real solutions. Okay? So what does that mean? Well, what happens is, and I'll tell you what it means, because if you were to try to figure this out for yourself, this one here, because it doesn't cross, has a complex solution. So it has no real solutions, but it has, let's highlight that. This one, because it has no real solutions, which means it doesn't cross the x-axis. When we go to solve this algebraically, it has a complex number solution. Okay? So we're going to unpack that, and we're going to try to find what that is. So we're going to do this thing called completing the square. So we're going to complete the square of an equation, and then we'll see what we get. So let's jump into example 1. So that's what we're talking about, is what happens when we have a complex solution. How do we know what's complex and what isn't? So if I go in here and I say 3x, this is example 1. Why would I hit that? 3x squared plus 9x minus 6 equals 0. If I want to solve this by completing the square, completing the square rigs the problem in a way that you end up with a perfect square, and then you take the square root. So the first thing that you would do is move the c. So I'm going to add 6 to both sides. So we're going to make it look like ax. So step 1, we're going to make it look like ax squared plus bx is equal to negative c. So I've got 3x squared plus 9x is equal to positive 6. Okay? All right. So now the next thing we do, step 2, is we're going to add to both sides b over 2 squared. And if we look at this as ax squared plus bx plus c, then we see that in the original equation, A is equal to 3, B is equal to 9, and C is actually equal to negative 6. So we have to think to ourselves, 3x squared plus 9x plus 9x, and then we're going to add, what's B? 9 over 2, and we're going to square it. And whatever you do on one side of the equal sign, you have to do to the other side. Oh, you know what I forgot to do, though? Erase this last bit. Erase all this. Erase all this last little bit stuff. One thing that we can do, and this is kind of nice, when you look at this, what do you know about 3, 9, and 6? Yeah, they're all divisible by 3. So what we're going to do is simplify this. It makes our math a little easier. So when I simplify this, I'm going to divide by 3. And as long as I divide all 3 terms by 3, then I get x squared plus 3x equals 2. So sometimes at this point, you can simplify if you're lucky. If you're lucky. Now, what made me think about that is I was like, 9 over 2, that's 4.5. When you square 4.5, oh man, that's going to be bonkers. And then I realized, wait a minute, all of these are divisible by 3. So I can reduce the whole thing. So now I'm going to do the same thing. So what that does is that changes the dynamic of this whole thing. And so now A equals 1, B equals 3, and C equals negative 2. But the process is the same, so I'm going to say x squared plus 3x, and then add 3 over 2 squared to both sides. So I'm going to say plus 3 over 2 squared plus 3 over 2 squared. See how that works? So then when I square, let's figure out what that is. So we'll just do it on the calculator for time's sake. So go ahead and hit second quit. Hit math. Go over to numbers. Go to fractions. And we're going to say 3 over 2. And then just square it like this. Hit enter. And you get 9 over 4. So I've got x squared plus 3x plus 9 over 4. And then on this side, I've got 2 plus 9 over 4. So now what I need to do is I need to think of a number. This is a perfect square. So we've rigged this so it's a perfect square. And it's actually x plus 3 over 2 squared. And so the third part of this process is factor, square, and then the fourth part of this process is to take square root of both sides. So this is equal to, and if I do the math, 2 over, to make this 2 over 4, isn't that 8 over 4, right? Plus 9 over 4, I need a common denominator, right? So I'm taking 2 and putting it over 1 and then multiplying the top and bottom by 4. And so in the next line, I get x plus 3 over 2 squared is equal to 17 over 4. And so now that I factored that, I could take the square root of this and the square root of this, and I get x plus 3 over 2 is equal to plus or minus the square root of 17 over 4. So then in the next step, I'm going to subtract 3 over 2, so I get x equals minus 3 over 2 plus or minus the square root of 17 over the square root of 4. Now I wrote it that way on purpose. What's the square root of 4? The square root of 4 is 2, so this is plus or minus the square root of 17 over 2. And because they're the same denominator, I could literally write it like this. Plus or minus the square root of 17 all over 2. Now that sounds and seems weird, but that is the solution. And it's two solutions, two real solutions. Now this is going to be hard, and we're going to have to do tons of examples like this. But that's how you do it. Are there any questions on that?